So this lesson today will be on a review of simplifying radicals, which hopefully you learned in Algebra 1, but if not, don't worry. We're going to pretend that you never learned it. So all of these problems are going to look like, you have like a radical, and then inside there's a number, and we want to split it up because those numbers are not perfect squares. So the first thing that we have to be aware of are our actual perfect squares. So perfect squares are numbers like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So you really want to know this list, if you can, all the way up to 20 squared. If not, up to like 15 squared should be enough. So let's go list them out. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and then we would have 49, that's 7 times 7, 8 times 8, 64, 9 times 9, 81, 10 times 10 is 100, we're going to go up to 400. 11 times 11 is 121, 12 times 12 is 144. You should know those. 13 times 13, I like to remember 369, so 13 is 169. 14 times 14, you just flip-flop the 9 and the 6, so that would be 196. 15 times 15, you can remember 5 times 5 is 25, so 15 times 15 is 225. And then 16 times 16 would be 256. 17 times 17, I like to remember 7, 8, 9, 289. 18 times 18, I don't know how I remember this, but it's 324. And then 19 times 19 is the one that I usually forget. Let me just double check. I think it's 361, but just to be sure, yeah, 361. And then 20 times 20 is 400. Chances are you're not going to use these upper ones too much, probably only up to this 225, but it's good to know all of them, especially going into Algebra 2 next year. The more you practice them, the more you will remember them. Okay, so what we're going to do in order to simplify these problems is we'll take the number, and we want to rewrite the number. We're going to break it up into 2 square roots. Leave a little more room there. The first square root, you want it to be one of the perfect square numbers. And then the second one will just be the leftover. And then what you'll do is you'll actually simplify that perfect square, and you'll get an actual number. And then this leftover, you're just going to bring it down and leave it. Don't do anything with it. So you'll see when we try some examples. So it might be helpful to also have this list of the perfect squares on the side, going in order. So 1, 4, 9. Just go ahead and list them out on the side, or maybe you want to put them on an index card and just keep that index card when you're practicing in class. Come time for a quiz or test, you'll have to know them, but as we're practicing, you're definitely going to become more familiar. I'm just going to stop there because I don't think we'll need anything higher than that. Alright, so what we're going to do is look at square root of 28. So first thing I want to think about is what's half of 28. So half of 28 would be 14. You know that the perfect square number, it can't be anything more than half of that. So now I'm going to go to my list and find all the numbers that are less than 14. And I'm going to start working upwards. So I'm going to try 9. Can I divide 28 evenly by 9? No, so it's not 9. Then try 4. Can I divide 28 evenly by 4? Yes, it would be 7. So then I'm going to break this up, square root of 4, square root of 7, and that becomes 2 radical 7. The words radical and square root, they're interchangeable. They mean exactly the same thing. So you can say radical or square root. Now the next one. This is an interesting one because if you notice, it's actually on our list of perfect squares, and the square root of 196 is 14, so you don't have to do anything with that one. If it was square root of 9, you would, like if it was like this, square root of 9, you would just write 3, whatever it is, you can just simplify it. Alright, so now 384. You definitely want a calculator for these to check. So 384 divided by 2. So half of that is 192. So I'm only going to be checking numbers lower than 192. I don't think it's divisible. We're starting here with a 169. I don't think that's going to work, but it can't hurt to try. So 384 divided by 169. No. So it has to work out evenly. So next I'm trying 144. No. 121, I know it won't work, but it can't hurt to just check it, right? 100, we know it's not going to be divisible by 100, so we're just going up this list checking them. Let's try 81. 84 divided by 81. No, it still doesn't work. Maybe 64. Nope. Maybe 49. So there won't be too many of these where you have to check like so many. 49 didn't work. Let's try 36. No, I'm still not getting a whole number. I know it can't be 25 because that would end in 2550 or 00. So let's try 16. Maybe this one. So 16 worked, but I think we might have to actually go again. So that means we might have missed something. So let's see. Square root of 16, and then the leftover was 24. So square root of 16 is 4. We can bring this down. So that means I must have missed something or typed something wrong on my calculator, which happens because I can simplify further. Because 24 also has a perfect square that goes into it. So if you think, whenever something ends in 4, it's usually, well, it's always divisible. Well, not always, but usually divisible by 4, right? So let's just see. So 24, half of that would be 12. And we know 24, if we're going through the list, it's not divisible by 9, but it is divisible by 4. So what we're going to do is just break that up again. So this becomes 4, and then the 24 splits up to 4 times 6. So that becomes 4 times 2, radical 6, which is 8, radical 6. And I'm actually very glad this happened because, you know, it happens often where you might have to simplify farther. Like maybe you don't get it the fully simplified way on the first try, and that's okay. You can just simplify that leftover piece again. You just have to recognize that that leftover piece is divisible by another perfect square. Also, you are probably wondering where I got this 24 from. Just to explain again, the 24, same way up here in number 1, the 7 came from the fact that 28 divided by 4 is 7. So here 384 divided by 16 is 24. That's where that came from. Alright, so let's try 98. So we're going to bring down that negative 2. If there's a number on the outside, you're just bringing it down, and then you're writing out your radicals, and then we'll just multiply that negative 2 at the end. So half of 98 is 49. And 49 is actually one of our perfect squares. So it's 49 times 2. That gives us 98. So bring down that negative 2. Put a little times. Square root of 49 becomes 7. Then we have a radical 2. So overall, we're just going to multiply those outsides. Negative 14 radical 2. Alright, so now let's try 448. So half of that would be 224. So let's check everything below that. So let's see. I don't think it's divisible by 196. Probably not 169 either, but you can check. I think I know what it's going to be, but let's wait till we get there. 144. No. 121. No. What's next? 100 definitely won't be, right? 224 divided by 81 is the next one on the list. 64 is the next one on the list. Still not working. 49 is next. Nope. 36. No again. 25 definitely won't work. Let's try 16. Yes, finally. So 448. It breaks up to 16 times 14. square root of 16 becomes 4. Everything else just comes down. Put a little times between there so we don't think it's a 34. And then that becomes negative 12 square root of 14. And then we know we can't go farther because the only numbers below 14 on the perfect square list are 9 and 4, and those won't be dividing into 14 evenly. Like I said, these ones with the big numbers, like number 9 and number 5, you won't see too many of them, especially on the test or quiz. We're really just doing this to prepare us for something with the special right triangles. So you won't have to actually do these on the quiz. It will be kind of using that to do something else. You do have to know it, but we won't be dealing with such huge numbers. All right, so now the next page we have these radicals where they are multiplied together. So the way that we're going to deal with this is we're going to make it one radical and just multiply the numbers inside. That's it. So square 3 times 3 becomes 9, and then that was really nice. With square root of 9 is 3. It's a perfect square. Now anytime you have this where you have like square root of a number, I'm just going to put a random number. Let's say square root of 23 times square root of 23, it's just going to be that number, no matter what that number is. So here it was 3 and 3 and 3. And this is going to be a really, really key idea when we go to our special right triangles. So no matter what the number is, square root of 7 times square root of 7, it's going to be equal to 7. Okay, so the radical kind of just cancels itself out. So here we have square root 10 times 2, which is 20. Half of 20 is 10, so let's see, 20 is definitely not divisible by 9 if we're going through our list. It is divisible by 4, specifically 4 and 5, and then that becomes 2 radical 5. Next we have 3 and 15. Now if you want to skip this step where you're writing that out, that's not a problem. Let's see, 45. Now also, if you can tell right off the bat which number perfect square goes into this, like for example 45, you know it's divisible by 9, you don't have to do the whole half thing. Just make sure that you can't go any farther. Make sure you chose the biggest one and not the smallest one. 9 times 5 is 45, so this is 3 radical 5. And then we have negative 2 times negative 3 is 6. And then you should recognize this, radical 5, it's going to be 5, but let's just kind of prove it. So this would be 5 times 5, bring down the 6, 25, and then the square root of 25 is 5. So overall, since we have that 6 on the outside, the 6 on the outside comes from these negative 2 and negative 3 on the outside. They multiply to 6. So overall, this comes out to be 30. Alright, and then the last one, we have 2 and negative 4, which is negative 8. So outsides stay together outside, insides go together inside, 12 and 3. So that's negative 8 radical 36, and that's one of our perfect squares. Square root of 36 is 6, because 6 times 6 is 36. So we're just going to write this out, negative 8 times 6, which is negative 48. Okay, I believe we're going to save the next page for tomorrow, or next class, whatever. So what I'd like you to do now is go back and try all of the evens that we skipped. Hopefully I wrote a note to you in the video that you should have tried the 1 through 10 evens before watching 11 through 12, but if not, it's fine. You can just go back and try the 1 through 10 and then try the 12 through 20 evens as well. So pause the video, try those, and then when you resume, I'll have the answers showing for you. Alright, so take a look, check out your answers on the evens. If you have any questions, please email me. Or, you can email me, and also, like, maybe if you didn't get number 6, put a big star on number 6. Tomorrow we can ask about it in class. Alright, and then let's go and check the evens on the second page. Again, we had in number 14 that situation, square root of 8 times square root of 8 is just 8. I had one more here. Also, sometimes you can't simplify. Like, for example, square root of 10. Half of that would be 5, and 10 divided by 4 is not going to be a whole number. And the only thing below that is 1, and they're all divisible by 1. So you can't simplify any farther there. And then there's our last one. So like I said, you probably want calculator, especially for these bigger numbers. Your homework for this section will be to, just kind of skip through the next pages and find numbers 37 through 58. It's, I think, 22 problems, so you can skip any 4. So that way you're just going to do 18. So pick the ones that you want to skip and then do the rest. And if you want to do all of them, do all of them. All right, I hope you have a great rest of the day. Again, please email me with any questions you might have.